Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve.
Good morning, and I'm Scott.
Together, we're Backyard Musings, the Science and Technology channel.
Yep, and we're talking about a little weather situation today. Climate, weather.
This
yeah,
is very
this is a good one.
interesting analysis. Putting all the data together to analyze this. Droughts and floods can upend lives, disrupt natural systems, and strain economies around the world. Scientists at the University of Texas at Austin are working to better understand these extreme water events by tracking how they appear and evolve across the globe. Over time, their findings point to a powerful climate pattern that plays a central role in shaping these extremes. Would you like to know more?
A study published in AGU Advances on November 20th, 2025 reports that over the past 20 years, ENSO, a recurring climate pattern in the equatorial Pacific Ocean that includes El Nino and La Nina, which is what we're in right now, is a La Nina year, has been the leading force behind extreme changes in total water storage worldwide. The researchers also found that ENSO tends to align these extremes, causing far apart regions to experience unusually wet or dry conditions at the same time.
Yeah, so what you're looking at right here is a map of the globe without Antarctica, it looks like. And it's superimposed. There's 5 layers, and that's, I think, a 5-year pattern.
5-year, 4-year. I mean, 4 layers, 5 years.
4 year. Yeah.
4
5-year pattern, because they said over 20 years. Right?
Gotcha. Yep.
Yeah. All right. A study co-authored Bridget Scanlon, a research professor at the Bureau of Economic Geology, that's weird, at the UT Jackson School of Geosciences, said that seeing water extremes from a global perspective has important implications for humanitarian planning and public policy. Quote, looking at the global scale, we can identify what areas are simultaneously wet or simultaneously dry, Scanlon said, and that, of course, affects water availability, food production, food trade, all of these global things.
When multiple regions face extreme water conditions together, the consequences can ripple through food systems, supply chains, and international cooperation. Total water storage is a comprehensive climate measure that accounts for every form of water in a given area. It includes surface water in rivers and lakes, snowpack, moisture held in soils, and groundwater stored underground. By examining this full picture, scientists can better capture how water systems respond to climate systems. And yet, California still hasn't figured out a way to store water. So,
nope.
Anyway.
Let it run into the oceans, what they do. This research is among the first to examine total water storage extremes alongside ENSO, the El Nino Southern Oscillation, on a global scale. According to lead author Ashraf Rateb, a research assistant professor at the Bureau, this approach allows scientists to see how extreme conditions are connected across regions.
Quote, most studies count extreme events or measure how severe they are, but by definition, extremes are rare. That gives you very few data points to study changes over time. And that's according to Rateb. Going on with the quote, instead, we examined how extremes are spatially connected, which provides much more information about the patterns driving droughts and floods globally, unquote.
Okay, I'm going to show how they do that right there. So this graphic here has got each vertical is a time period, like a 4-year time period. You can see the 2000s, the 2010s, the 2020s, and it's the same areas that are being looked at. And at the top, you can see the distribution of what it looks like. Okay, to estimate total water stores, the research team relied on gravity measurements collected by NASA's GRACE and GRACE follow-on, GRACE FO satellites. These observations make it possible to detect changes in water mass over areas roughly 300 to 400 kilometers across, similar in size to the state of Indiana. The scientists defined wet extremes as water storage levels above the 90th percentile for a given region. Dry extremes were identified as levels below the 10th percentile.
The The results show that unusual ENSO behavior can push widely separated regions into extreme wet or dry conditions at the same time. In some places, El Nino is linked to dry extremes, while in other regions, dryness is tied to La Nina. Wet extremes tend to show the opposite pattern.
The study highlights several notable cases in the mid-2000s. El Nino coincided with severe drought in South Africa. Another El Nino event was linked to dry conditions in the Amazon during 2015-2016. In contrast, La Nina during 2010 to 2011 brought exceptionally wet conditions to Australia, Southeast Brazil, and South Africa.
Beyond individual events, the researchers also identified a broader change in global water behavior around 2011 through 2012. Before 2011, wet extremes were more common worldwide. After 2012, dry extremes became more frequent. The team attributes this shift to a long-lasting climate pattern in the Pacific Ocean that influences how ENSO affects global water systems.
Yeah, crazy. Because GRACE and GRACE-FO data are not continuous, including an 11-month gap between missions in 2017 to 2018, the researchers used probabilistic methods based on spatial patterns to estimate total water storage extremes during periods without satellite coverage.
Although the satellite record spans only 22 years, which is what was on that graph earlier, 2002 to 2024, it still reveals strong links between climate cycles and global water behavior, says J.T. Rieger, Deputy Project Scientist for the GRACE-FO mission at NASA's Jet Propulsion Laboratory in Pasadena, California, and the JPL Discipline Program Manager for the Water and Energy Cycle. Scanlon said that the findings also reinforce the need to view floods and droughts as natural parts of the climate system that require preparation and management. So the way I always understand this El Nino and La Nina pattern, for us anyway, here in the desert Southwest, is usually La Nina is will have a wet year, but it will be warm wet. So in other words, the mountains won't be getting a lot of snowpack, maybe up very, very high. And that's what's happening right now. Utah, Colorado, California, I mean, they're getting snow, but not like they've had in the past. El Nino, on the other hand, is the same type of pattern, but it's usually colder. The weather comes down from Alaska and Pacific Northwest. But again, I'm not a weather guy. I don't claim to be a weather guy. But
you're not an expert? You're just a messenger?
I'm not an expert in anything except making my wife mad. But the other... so that's kind of the way I remember it. So we have wet patterns, La Nina, warm weather, wet, warm, El Nino, wet, cold. So we're in a La Nina cycle right now, I guess, and it's not helping. So, I mean, it's great for the weather, but it's not helping our snowpack, and that's where we get a lot of our domestic water from. So.
This is really interesting data analysis. It's pretty cool.
Yeah, it's interesting to me that they're utilizing organizations that normally track stuff in space to study these patterns, which I guess it still is in space. I guess it's up in the atmosphere. So it's kind of cool. I didn't even realize that Jet Propulsion Laboratory got involved in that kind of stuff, but they're good at what they do. So that's good to have these things. So,
all right, folks, thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Thank you. We'll see you this afternoon.